Hi, Joyce. All right, here we go, section 9.2. Our goal today, real quick, Joyce, is to get through L'Hôpital's as many examples as possible, let people just work on homework. Tomorrow, go over the couple questions from 9.1 that people might have had on homework last night, and any remaining questions on 9.2. L'Hôpital is pretty straightforward, so I figured all of us could use kind of a work day, myself included. Oh, sorry. Tomorrow I should be here to go ahead and record for you, Joyce, so that way you can just access it. Access it online. I'll do the best I can. I might go ahead and save it old school on the flash drive, just that way it's easier, so you can go ahead and just plug in the flash drive and play it from there. Sound good? Okay, here we go. Section 9.2, L'Hôpital's rule. We have indeterminate forms. Boop, there they are. Why are the first two circled? Yeah, because they're the ones we want. Because L'Hôpital's rule wants an f over g in order to be able to solve, right? We did an easy one yesterday with e to the 2x minus 1 all over x, the limit as x approaches 0. We plugged in, we were able to solve. There we go, there we go. This one we didn't finish. How would we finish though? Yeah, we can keep going. Because one more iteration is going to go ahead and get us. What do we got? Positive sign, right? All over 6x, still 0 over 0. The book calls this the stronger form. The stronger form, according to the book, is just our normal form that says, hey, you can go as many times as you want. Derivative of sine is cosine. All over 6. Why do we keep going? Because now we have an over 6. It's a possible answer. We're good to go. Just figure out what cosine of 0 is, and it's that. So can you repeat L'Hôpital's rule and do it multiple times? Oh yeah. So what did you guys do with this one? Limit as x approaches 0 of 3x minus sine of x all over x. First of all, don't do L'Hôpital's if you don't need to. But who is this?
0.
Yeah. Okay, so L'Hôpital's. You guys are BC, we'll just go straight for it and not stress about showing all the notation every time. Cool. Let's see if I can beat you, because I can write fast today. Done. 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 Well, at least the line lets me work on it ahead. There it is. Yay! Did you guys get the right answer?
Yes.
Hey, maybe I like the lag after all. So that one was pretty easy. What about this one? Style back the animosity. Pretend it otherwise. I actually want you guys to look at this one. If we were to solve this limit, what would we get? So it's two infinite forms, yeah. And if we were to actually go through and solve, we might actually realize that one is DNE and one is 1 over 0. But either way, we kind of have the idea of infinite and infinite. We're in trouble. So what are we going to do instead? Oh, derivative of the top and the bottom, except there isn't one. This is an indeterminate form, but it's not the one that we want. So what do we do before we do L'Hôpital's? Change the form. Oh, there's no lag. Oh. For common denominators, right? Why? Do we have a top and bottom now? Oh. And since we have a top and bottom now, we can think about plugging in 0 now. Now do we have 0 over 0? See, 0 over 0 is an indicator like, hey, we're ready to go with L'Hopital's. How ready to go? Well, prime. Let's struggle in denominator. Mm-hmm. One minus 1 is 0 over sine of 0 is 0 and 0 times cosine is 0. Maybe this one's impossible? Or maybe, yeah, let's try again, just see what happens. Some of you might think there's a rabbit hole. Let's see. Let's show some perseverance and say, well, what else are we supposed to do? Let's just keep on doing L'Hopital's, no? Alice in Wonderland, going down the rabbit hole. It's an allusion to you're kind of going towards an impossible problem. Where you're getting further and further away from truth or reality. Does that make sense? Oh, wait, no. Sine of 0 is 0, all over. Cosine of 0 is 1, plus 1, minus 0. Dun 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 dun. You see it? 0 over 2 is fine. I just don't like 0 over 0. Does that make sense? Everybody caught up? So about this guy. Since we have our Endeavor card, we can say, wait a minute, we know who this guy is. Question, how can we show it?
This reminds me of that little picture you have on your tabs on your website. It's like, and a miracle occurs.
Yeah, we wish, right?
Yeah.
Yay, this will be our miracle. We could do that.
We can do x plus 1 quantity to the power of x over x to the x, you know? And then like put a limit on top and bottom.
Ooh, what am I doing?
Natural log. Huh?
Natural log.
There's one with natural or with log base 2 of x. No.
Oh, that's dumb. Why is that there?
It's ln something over log base 2 of x.
We can just do
You do change a base formula.
Yeah, I know you can.
That doesn't mean she enjoys it. What am I about ready to do? Has anybody noticed why it's indeterminate? What was it up here? 1 plus 0, 1 to the infinity, right? That's indeterminate. Once you get here, what would it be? 0, 0 times 0? No.
I would choose natural log.
This would be 0 times infinity. You wouldn't. Not that I know of any of them. Don't we want a top and a bottom? And this kind of goes along Charta with the whole sine of 1 over n1. Because we can make a fraction by taking the multiplication by x and making it division by 1 over x. Taking the multiplication by x and making it division by 1 over x. Oh, now it's not happy. There it is. Is that legal? Yeah. Is it creative? Oh, yeah. That's legal. Why did I do that? Because now what do I have?
Fraction.
0 over 0. What we tell us? How? Derivatives.
1 over, I guess x over x plus 1.
For 1 over u. Yeah, then we're going to need d prime. So this one we have negative 1 over x squared, right? For the denominator. Numerator, we have 1 over x plus 1 over x, which is just multiplied by the reciprocal x over x plus 1 times quotient rule. Bottom be top. That's a good so far.
I got negative 1 over x squared plus x.
Yes. So I'm going to go ahead and do negative 1 over x times x plus 1. Which ends up equaling
How did you get the over 1 over x squared?
you have to do g prime, f prime over g prime. So my g was 1 over x.
Oh, yeah.
Right, so then I take the derivative of negative 1 over x squared, just using power rule, yeah?
Yeah. Oops.
So I end up with x squared over x, which the x squared and the x can reduce. So I end up with a positive x over x plus 1. Exactly. Good, I hadn't brought it up in a while. So now what? Ooh, what's the limit as x goes to infinity of x over x plus 1? Can't we jump there? True, which is technically L'Hopital, so we can take a derivative, which would be 1 over 1, which is 1. But couldn't we also do degree tests? And say the degrees are tied, but both ways work, right? But that's not E, we're wrong. No, we're right, because how do we solve for Y?
This Pearson needs the charter for your
See the backpack that's like upright?
Yeah.
Look inside. There should be a gray leather pouch. Yeah, just inside. Perfect. It's in there.
Okay. Cool.
How are thinking? E to the and y is equal to dun, 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 dun. But are we going to memorize this? Yes. And remember it? Yes. So we don't have to do all that work every time? Yes, yes, yes. Yay! Alright, go team. What else do we got?
How do they do that without knowing that there's such thing as a natural law?
Who's they?
Whoever invented that.
That one problem with that one solution. I'm not sure if they invented that one problem with that one solution before such a thing as a natural law. Because I believe natural law is dependent upon E. E is dependent upon, well, technically nature, I suppose. So maybe E came first, then natural law?
That makes
Because any function needs an inverse, right?
that makes sense.
Good needs a bad, yin needs a yang. Wait a minute, isn't that the same person? What? Man, George said Peyton was good and bad.
Oh, yeah.
It's getting to be quite a monumental day.
And it's really bad at being bad.
Okay. What now? Round count?
It's
No.
0.
Oh, that's pretty funny, I won't
No,
lie.
wait.
And we're recording, go team. 0 times ln of 0. Oh no, that's a vertical asymptote. That's negative infinity. 0 times negative infinity is indeterminate. Uh-oh, but what do we need? A fraction. How do we get it?
1 over x squared.
A power, we'd have to do that whole ln yuckiness from before. I don't think we want to do
ln x over 1 over square root of x.
that. Yes. Make that multiplication division by a reciprocal.
Should we make the square root of power now?
I did. Oh, sorry, you can't see it. No, see anything. Yes, I would make it a power. So then we can go ahead and say technically negative infinity. I'll just so we can visualize.
How is ln of x negative?
Ah, because ln of x, remember his nature?
Oh, yeah.
Where are you? Where are you, buddy? What's up? Good short now. There it is. So we'd have ln of x, which is negative infinity over 1 over x, which is positive infinity. Ultimately, we get infinity over infinity. Struggle. That's L'Hopital's, right? So then we have the limit as x goes to 0 of 1 over x all over
Oh. Yeah,
I take the derivative x to negative 1/2, bring down negative 1/2, subtract 1. We have x to the 3 halves. Negative 3 halves, but there we go. We can simplify that, right, guys? Just with algebra?
I didn't do
Like bases? What do you do with the powers?
Subtract.
Subtract.
My brother was doing this.
Hey, see, look, it applies. It's the same thing as limit as x approaches 0 of negative 2 square root of x. Now we would be in some serious trouble if I didn't say right about now there's a typo. Why does that have to be true for this whole problem to even be approachable? Because ln, yeah, the domain is restricted to only be able to come from the right. So therefore I need to go ahead and theoretically add little pluses to all my little different places, which I'm not going to do. I'm just going to throw them in and say, oops, that's right. And why did I say that? Because the square root of x is restricted as well. So now plug in 0 and I get dun 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 dun. Alright, kiddos, L'Hopital's. How do we do?
I messed up somewhere. I got 1 over x over 1 over 1 over negative 1 over 2 root x. So I got 1 over x over
1 over negative 1 over 2?
Yes.
And that's where you messed up. Because you're just taking the derivative of x to the negative 1/2.
I did the derivative of.
X to the negative 1/2.
Oh, that's where I messed up.
There we go. You were trying to skip the quotient rule.
Yeah. Oops. That's what I realized.
Alright, with that, let's go for it. Sound good? Let me go ahead and put up your homework so that you guys can see. Cool.
Does anyone else need a book?
To be honest, tomorrow's notes are probably not going to take super long either, and I might go ahead and start with the lesson. That way I can get it recorded for Joyce before I have to leave. And then we'll end with questions, because she usually goes to the solution manual anyway. She's cool. Does that sound good?
You didn't bring your book today.